Hi, we're here today at the AIM Motorcycle Expo, and we're going to talk about engine oil and why motorcycle engines put unique requirements on oil that automotive products just will not handle. So let's think first about the typical car engine, and then we'll think about motorcycle engine. Typical car engine has a very large sump capacity versus a motorcycle. It's liquid cooled, so it maintains a fairly constant temperature. And it basically the engine oil only has to handle the engine. There's a separate gear oil in the car, and there's a separate transmission oil. Now let's think about a motorcycle. Motorcycles have a very small sump capacity. They put out more horsepower per cubic inch than any car will. In many instances, the engine oil also lubricates the transmission as well as the clutch system. Further, even our motorcycle engines, which are air-cooled, can also, due to heat, thermally stress oil. So, what conclusion can we draw from that? Well, if you were an oil manufacturer and you were a multinational oil manufacturer, typical of some of the largest oil company in the world, or many of the larger mini majors, you would love to have one oil that will satisfy both car requirements and motorcycle. That's no longer possible. All of the major oil companies in the world have realized car oils went that way a while ago, and motorcycle oils went that way, specification-wise. And let's chat about why. Well, first off, if you're using an engine oil in a car, you don't have to worry about shear stability as much as you would in the engine oil of a motorcycle. The thing we use in our industry to build viscosity are called viscosity index improvers. And in a passenger car, you can use one that's not as shear stable because in a motorcycle, particularly say a Japanese motorcycle, where the engine and transmission commingle the fluid, the oil is run through a gear. And what happens when this polymer, which is a plastic, is run through a gear, if you can think of it as sort of like a spider, when it's cold, its legs are tucked in. And as it heats up, the legs come out, and so it resists flow. That's how we get viscosity increase. The problem in Japanese motorcycles is when these polymers run through the gearbox, they suffer a shearing. So the legs get sheared, and they don't regenerate. So what happens is you have viscosity loss. Okay? And there are two types of viscosity conditions that can cause this. There can be a mechanical shearing, and then there can be shearing due to heat. So both Japanese-style motorcycles and air-cooled motorcycles can have the problem. One suffers mechanical shear, the other suffers shearing from heat. First thing you do when you're going to build a motorcycle-specific product is you pick a polymer or viscosity index improver that is very shear stable. It costs you more to do that, but that's the only way you can guarantee that the product will stay in grade for the whole service interval that you're trying to achieve. Second thing you have to worry about is additive technology. Due to the fact that the car runs at a very lower RPM range normally and a very lower operating temperature, you don't have to worry about the additive technology quite as much. motorcycles tend to run higher RPM and higher heat. So you need more additive technology. In particular, you need more zinc and phosphorus in motorcycle-specific products than you would need in car oils. The thing that zinc and phosphorus do is they give us extremely good anti-wear, and they give us what's called their antioxidants. Heat tends to try and thicken oil. So what will happen is, over time, as an oil oxidizes, it becomes thicker. If you let it go to the far end of that, it'll actually become sort of like yogurt or even thicker material, and you can have an engine failure due to thickening. So you have to be very careful about the amount of zinc and phosphorus in the products you use in your motorcycle. Car products, because of the limits placed upon them by the Environmental Protection Agency and the government, have a maximum zinc phosphorus level now of about 800 parts per million. The JASO products that are available in the motorcycle industry, JASO MA in particular, has a limit up around 10,000 or 1,550 parts per million for zinc. And so there's a significant statistical difference there, very much so. In the car oil, they can have a minimum of 600 parts per million, but only a maximum of 800. Meanwhile, we can build our products to just under 1,100 ppm. So there's a very big difference in that. If you use really good polymer and you use really aggressive additive, you build a much more strong product that'll stand up to the rigors of motorcycle operation. Also, when you get into car oils, the real thing that car oils have that really motorcycles don't want any part of are what's called friction modifiers. And passenger car motor oils in particular these days, everybody is into fuel economy. And the only way you can build fuel economy is through lighter viscosity fluids. When I first got in the business years and years ago, that's many years ago, the predominant viscosity you would find in most automotive shops would be a 1040 or a 20W50. If you go into those types of shops today, most of the products you see are a 530, 520, and even 0W20, and soon to come a 0W16 product. And that's all because of fuel economy concerns by the car manufacturers. On top of viscosity, one of the things that helps with fuel economy is our additive technologies, which we call friction modifiers. And if you put those friction modifiers into, in particular, Japanese motorcycles, they make the clutches slip. So they're inappropriate for any motorcycle application. They absolutely give problems. And back around 1994 and 95, the major Japanese motorcycle manufacturers presented an SAE paper that basically outlined these problems that they saw cropping up in the field. They didn't like the viscosities that they were seeing available. They tend to like a 10W30, 10W40 product. They were seeing 530 introduced, and it was causing problems with wear. They saw shear stability as being a problem, and they saw additive technology being a problem in lack of zinc phosphorus, and also a problem with friction modifiers. So they actually came up with the Japanese Automotive Standards Organization JASO MA specification, which addresses shear stability, it addresses additive technology. These are very, very important topics if you want to ensure the longevity of your motorcycle. And while we can't get into a lot of the real technical details today, certainly if you contact Spectro oils, we'll be glad to talk to you about this in further depth. But in general, the additive technology that really is required for motorcycles and cars went in opposite directions from about 1985 or 86 onward, and has gone opposite direction ever since. And I think one of the reasons that this isn't really addressed is I think it's a lack of, on our part, to educate the motorcycle owner. We really haven't done enough work to let them know that there's really a difference. And let's face it, the other thing is that it's easier for the consumer to go into an automotive shop or a car parts store than it is a motorcycle shop. They're much more prevalent, and they see things in the rack that should be able to work for them, but they're really not appropriate for the use that they have. So therefore, for those reasons, you want to use a motorcycle product in a motorcycle and a car oil in a car. That's the end of the discussion. You really have to use the correct product in the correct application, and that will ensure longevity. One of the other problems we have is if you really want to build a very good motorcycle-specific product, it's going to cost you more money. It's easier to build a car oil because you don't have to use as expensive or as shear stable a polymer. You don't have to use as much additive technology. That adds to the cost. And the polymer is expensive as well. These all add to the costs. So when you end up with the finished product, yes, it does cost you more, but think of the investment you have in your motorcycle. It's a significant investment, and if you want to ensure its longevity and peak performance, you want to use the correct product, and that's a motorcycle product. That being the general discussion ended, I was wondering if anybody had a specific question we can answer on motorcycle lubricant. Yes? The question is, what types of additives make motorcycle oils different? And really the crux of the thing is zinc and phosphorus. They have been limited in automotive content because of catalytic converter considerations. And they have been limited consistently from about 1992 onward, to the point now where you have a min of 600 and a maximum of 800 parts per million for zinc in passenger car motor oils, where a JASO MA product would have a maximum allowed of a little under 1,100 parts per million. So that statistically is quite a lot, particularly if the passenger car motor oil builds to the lower end of the viscosity, you know. And particularly one of the things we do at Spectro, which helps us when you're building a motorcycle product, there are a couple of things you can do. Everyone is familiar with Society of Automotive Engineers. Well, they're the people that tell us what a viscosity is. And viscosity is just basically resistance to flow, okay? Now, SAE tells us what a 10W40 motor oil is. And they'll tell us and how we measure it is using this machine. It's called a viscosimeter. This is an old style machine. We actually have an automated one, but the concept is the same basically. What you have is an oil bath system with a fixed size reservoir, and you have a beaker under it with a hash line at 60 milliliters. And you bring this viscosimeter up to the temperature you wish to test at. And the one we really like to look at is 210 Fahrenheit, which we would consider operating temperature, okay? So we bring this oil bath system, oh, and it has a fixed orifice at the bottom, which, believe it or not, in the old days it had a little cork you put in there, okay? And what you do is you bring this up to temperature, 210, with the reservoir filled with the